Welcome to the Deep Dive,
Cool.
where we take a deep dive into a source you provide
Yeah.
and kind of glean all the insights and knowledge that we can from it. Today, we're diving into the fascinating world of El Niño
Right.
and its global reach, guided by excerpts from the Wikipedia article on the El Niño Southern Oscillation, or ENSO for short.
ENSO. You can think of ENSO like a giant seesaw in the Pacific Ocean, constantly rocking between warm, cool, and neutral states.
Oh, I love that. I love a good analogy. So what exactly, when we talk about El Niño, what exactly are we dealing with here?
Picture this. A massive pool of warm water, almost like a giant bathtub, sloshing across the Pacific Ocean. When this warm water builds up in the eastern Pacific, we call it El Niño.
Okay, so we've got this warm water shifting around, but how does that actually impact the weather? It's just water, right?
It's not just about the water itself, but the chain reaction it sets off. The jerkness feedback mechanism is crucial here. Imagine dominoes falling one after another. Changes in ocean temperature trigger wind shifts. These wind shifts further alter the ocean currents, and so on, amplifying the initial change.
So it's like a chain reaction, multiplying the effects of that initial shift in water temperature.
Right.
But what flips the switch? What causes this warm water to slosh around in the first place?
That's the million-dollar question, and scientists are still debating the exact triggers. There are theories involving changes in air pressure, undersea currents, even events happening far outside the Pacific.
Yeah.
It's a complex interplay of factors, and unraveling that mystery is a big part of ongoing research.
Wow, so that initial trigger for El Niño is still a mystery. What a fascinating puzzle.
Well,
So speaking of things moving around, our source mentions the Walker circulation. What exactly is circulating here?
the Walker circulation is this massive loop of air flowing over the Pacific Ocean. Think of it like a giant conveyor belt,
Okay.
transporting heat and moisture across vast distances. Warm, moist air rises over the western Pacific, travels eastward at high altitudes, then sinks back down over the cooler eastern Pacific, completing the loop.
Okay, so I'm visualizing it now. This giant air conveyor belt is constantly moving, redistributing heat and moisture. So how does El Niño mess with this well-established system?
El Niño disrupts this delicate balance. When that pool of warm water shifts eastward during an El Niño event, it disrupts the Walker circulation, weakening or even reversing this airflow.
Whoa, reversing a giant conveyor belt of air. That must have some pretty serious knock-on effects, right?
Absolutely. It's like throwing a wrench into the global weather machine. These disruptions create a ripple effect, influencing weather patterns far beyond the Pacific, reaching continents across the globe. And that's where things get really interesting because we can actually track these changes using something called the Southern Oscillation Index.
Now that sounds intriguing. So tell me, how do scientists measure this southern oscillation? Is it something to do with ocean temperatures?
It's actually linked to air pressure. The Southern Oscillation Index, or SOI, is calculated by measuring the pressure difference between Tahiti and Darwin, Australia. These two locations are on opposite sides of the Pacific, and their pressure difference gives us valuable clues about the state of ENSO.
Wow, that's fascinating. So, by measuring the difference in air pressure between these two distant locations, we can actually tell what's happening with that giant pool of warm water.
Precisely. It might seem strange to use air pressure to track an ocean phenomenon, but it makes sense when you consider the dynamics. Warm water leads to lower air pressure, while cold water results in higher pressure. El Niño throws this pressure balance off, so by monitoring the SOI, we can get a good grasp of what's happening across the Pacific.
Okay, that makes a lot of sense. So now that we understand the basics of what El Niño is and how it's measured, I'm really curious to explore its impact on different regions. Let's start with Africa. What happens there when El Niño comes knocking?
El Niño's impact on Africa is particularly pronounced when it comes to food security. For instance, in southern Africa, El Niño often brings severe droughts, decimating staple crops like maize.
Right.
This can have a devastating impact on food supplies, leading to widespread hunger and economic hardship.
Yeah, that's heartbreaking to hear, especially considering the existing challenges of food security in many parts of Africa. It really highlights how interconnected our world is, how a shift in the Pacific Ocean can have such a profound impact on people's lives thousands of miles away.
It's a powerful reminder of the interconnectedness of our planet systems. But the story isn't always one of hardship. In East Africa, El Niño can actually bring increased rainfall, replenishing water resources and boosting agricultural yields. So the impacts can be quite diverse and region-specific.
Okay, so El Niño gives with one hand and takes with the other. It's a complex picture with both positive and negative effects, depending on the region. What about Asia? How does El Niño affect that vast and diverse continent?
Southeast Asia is particularly vulnerable to droughts during El Niño events. Remember Singapore's record dry February that was linked to El Niño? The lack of rainfall can severely impact agricultural production, especially for rice, a staple food in many Southeast Asian countries. This can lead to price hikes, food shortages, and economic instability.
Wow, so El Niño's impact can ripple through entire economies, but it sounds like the effects can vary drastically within a region.
Yeah.
You mentioned Singapore's drought, but what about other parts of Asia? Does El Niño always bring dry conditions?
Not necessarily. While Southeast Asia typically grapples with droughts, El Nino can actually increase the risk of typhoons making landfall in China. So it's a double-edged sword for the region, with different areas facing contrasting challenges.
A double-edged sword indeed.
Hmm.
El Niño certainly keeps us on our toes with its unpredictable nature. Now let's hop over to Australia. I know they've experienced some pretty devastating bushfires in recent years. Is there a connection to El Niño?
Absolutely. After an El Nino event, the risk of bushfires, particularly in Southeast Australia, goes up significantly. The hotter, drier conditions create a tinderbox-like environment, making it easier for fires to ignite and spread rapidly. The 2019-20 bushfire season, which ravaged vast areas of Australia, was exacerbated by a strong El Nino event.
Wow, that's a chilling reminder of the destructive power of El Niño. Those images from the fires were just heartbreaking, and the scale of the devastation was immense. Speaking of which, what about our own neck of the woods? What does El Niño mean for North America?
North America experiences a mixed bag of impacts as well. California generally sees wetter winters during El Nino, which can be beneficial for replenishing reservoirs and boosting water supplies. However, the relationship between El Nino and California rainfall is more complex than many people realize.
Oh, really? So it's not as simple as El Niño equals more rain for California. What are some of the complexities involved?
Well, the amount and distribution of rainfall can vary depending on the strength and type of El Nino event. Some El Nino events bring abundant rainfall to California, while others have a more muted effect. Additionally, the location of the warmest waters in the Pacific can influence the trajectory of storms, leading to variability in rainfall across the state.
So there's a lot of nuance to it. It's not just a simple on-off switch. El Niño brings a degree of unpredictability to California's weather patterns. But what about other parts of North America? Do they experience similar variability?
While California might welcome the extra rainfall, the Pacific Northwest and the Rocky Mountains tend to experience drier conditions during El Nino. This can impact water resources, increase the risk of wildfires, and affect industries like agriculture and forestry.
So El Niño brings a mixed bag of blessings and challenges to North America, just like it does to other parts of the world. Now, what about South America? They're right there in the Pacific, so I imagine they get hit pretty hard by El Niño's antics.
You're absolutely right. El Niño's impact on South America is particularly significant, especially for the western coastal regions. Peru and Ecuador are often hit hard, experiencing torrential rainfall and devastating floods during El Niño events. These floods can cause widespread damage to infrastructure, displace communities, and disrupt agriculture.
Wow, it sounds like El Niño really packs a punch when it comes to South America. It's incredible to think about the sheer force of nature unleashed by these shifts in ocean temperatures. We've got one more stop on our whirlwind world tour of the Pacific Islands. What happens there when El Niño rolls in?
The Pacific Islands, with their delicate ecosystems and limited resources, are particularly vulnerable to El Niño's impacts. Some islands, like Hawaii and Fiji, often experience droughts during El Niño events, leading to water shortages and impacting agriculture. Other islands, like Samoa, face an increased risk of cyclones, which can bring destructive winds, heavy rainfall, and coastal flooding.
So El Niño throws a curveball at the Pacific Islands, impacting their delicate ecosystems and water resources in a variety of ways. It's a reminder that even small changes in global climate patterns can have profound effects on vulnerable communities. Okay, so we've covered a lot of ground here, literally. We've seen how El Niño affects weather patterns all over the world, bringing droughts, floods, and a whole lot of disruption. But I think it's time to bring it home. Why should our listener, why you, care about El Niño?
What's fascinating here is that El Nino highlights how interconnected our planet truly is.
Yeah.
Changes in the Pacific Ocean, seemingly far removed from our daily lives, can have ripple effects across the globe, affecting weather, economies, and even ecosystems we depend on. It's a stark reminder that we're all part of a complex web of life, interconnected in ways we might not always perceive.
It's a powerful message, and one that's particularly relevant in our increasingly interconnected world. El Niño isn't just some abstract scientific phenomenon happening far away. It has real-world consequences that can touch our lives in a variety of ways.
Exactly. And that's why understanding El Nino is so crucial. It's about being informed and prepared,
Right.
recognizing the interconnectedness of our planet's systems,
Yep. Yeah.
and appreciating the complex interplay of factors that shape our climate and our lives.
It's about realizing that we're all part of this grand planetary dance, and that seemingly small shifts in one part of the world can have far-reaching consequences for the entire system.
And speaking of interconnectedness, there's one more crucial piece to this puzzle that we need to address: climate change. How does this global phenomenon, driven by human activities, interact with the natural rhythms of El Nino?
Ah, yes. The big question on everyone's mind: how does climate change fit into all of this? We've talked about El Niño's natural cycles, but I'm curious to know how human-induced climate change is influencing this powerful force of nature.
Well, the science is still evolving, but one thing's clear. Climate change is making the impacts of El Nino more extreme. We're already seeing more intense droughts, more devastating floods, and more frequent heat waves, and these extreme events are likely to become even more severe as the planet continues to warm.
So, even if climate change isn't directly causing more El Niño events, it's acting like an amplifier, making the consequences a lot worse.
Yeah.
That's a pretty sobering thought.
It is, and it raises some crucial questions. What role will El Nino play in our warming world? Will it become more frequent, more intense, and how will we adapt to these increasingly extreme events?
Those are some big questions and ones that scientists are actively grappling with. But one thing is certain. Understanding the complex interplay between El Niño and climate change is crucial for navigating our future on a warming planet.
Absolutely. The more we learn about these intricate relationships, the better prepared we'll be to mitigate risks, adapt to changing conditions, and build a more resilient future for ourselves and the planet.
Well, before we delve further into those pressing questions about El Niño and climate change, let's take a step back in time and explore El Niño's fascinating history. Our Wikipedia source mentions that there's evidence of El Niño reaching back thousands, even millions of years.
That's right. It's amazing what we can learn about past climates by looking at the Earth's natural archives.
So tell me, how do scientists unravel the mysteries of El Niño's past? What clues do they look for?
Scientists have found evidence of El Nino events in all sorts of paleoclimatic archives, in like coral skeletons,
Wow.
ice cores, even layers of sediment.
Wow, so those natural records hold the secrets of past climates. And they can tell us about El Niño.
Yes. These records contain a wealth of information about past temperatures, rainfall patterns, and ocean conditions. By analyzing these clues, scientists can reconstruct past El Nino events and understand how they've shaped our planet over vast stretches of time.
That's incredible. So what do these ancient records tell us? Was El Niño always around causing mischief?
It seems so. There's evidence of El Nino events during the early Holocene about 10,000 years ago. We've even found chemical signatures of warmer sea surface temperatures and increased rainfall caused by El Nino in coral specimens that are around 13,000 years old.
Wow. So that means El Niño was already making waves when humans were first settling down and developing agriculture.
Right.
I wonder how they coped with these unpredictable weather shifts.
It must have been a challenge for early civilizations dependent on predictable rainfall for their crops and livelihoods.
Yeah.
Imagine trying to plan your planting and harvesting around these erratic shifts in weather patterns.
I bet those early farmers would have loved to have a heads up about El Niño. It's fascinating to think about how these ancient climate patterns shaped human history.
It really is. And the Wikipedia article even mentions that El Nino may have played a role in the decline of some pre-Columbian cultures.
Oh, really? Which cultures are we talking about?
Well, one prominent example is the Moche civilization, which flourished in coastal Peru between the 1st and 8th centuries AD. They were known for their sophisticated irrigation systems and their impressive pyramids and temples.
That's right. I remember learning about the Moche in a history class. They were a fascinating and advanced civilization.
Indeed. But their reliance on a complex irrigation system made them particularly vulnerable to disruptions in rainfall patterns. And researchers believe that a series of intense El Nino events, bringing devastating floods and droughts, may have contributed to their decline.
That's a sobering thought. It really highlights how powerful a force El Niño can be, not just shaping weather patterns, but influencing the course of human history.
Yeah.
So we've got evidence from thousands of years ago, but what about even further back? Millions of years. Can we trace El Niño's footprints that far back in time?
That's where things get even more fascinating. A recent study suggests that El Nino might have played a surprisingly dramatic role in Earth's deep past. Researchers believe that increasingly intense El Niño events, possibly triggered by volcanic activity, contributed to the Permian-Triassic extinction event about 252 million years ago.
Hold on, the Permian-Triassic extinction. That's the biggest mass extinction in Earth's history. Are you saying that El Niño might have contributed to wiping out 96% of marine species?
It's a complex puzzle, and researchers are still piecing together the evidence, but the study suggests that El Niño events could have disrupted ocean circulation and nutrient cycling during that time, creating extremely harsh conditions for marine life.
Wow, talk about a ripple effect. It's incredible to think that something happening in the Pacific Ocean could have such profound consequences for life on Earth. So it seems like El Niño has been shaping our planet for millions of years, influencing weather patterns, impacting ecosystems, and even potentially contributing to mass extinction.
It's a powerful force of nature, and understanding its complex dynamics is crucial for understanding our planet's past, present, and future.
Now, before we wrap up this part of our deep dive, I wanted to touch on something else intriguing I found in the Wikipedia article. It turns out there are different flavors of El Niño. It's not just a one-size-fits-all phenomenon.
That's right. The classic El Niño, which we've been focusing on, is characterized by warming in the eastern Pacific.
Right.
However, scientists have observed variations where the warming occurs in the central Pacific instead.
Okay.
This is called El Niño Modoki, which is Japanese for similar but different.
El Niño Modoki, huh? So we've got classic El Niño and this similar but different cousin. I'm guessing they have different personalities, so to speak, and different impacts as well.
Absolutely. For instance, El Niño Modoki seems to be associated with more hurricanes making landfall in the Atlantic. It also affects rainfall patterns differently, leading to increased rainfall in northwest Australia rather than the eastern part of the country, which is typical for the classic El Niño.
So depending on where that pool of warm water decides to hang out, the impacts can vary significantly. It just goes to show that El Niño is a complex beast constantly throwing us curveballs.
And we can't forget about the cool phase of ENSO, La Niña, which is essentially the opposite of El Niño.
Oh, right, La Niña. We've been so focused on El Niño that we haven't even given La Niña much attention. So what's the story with La Niña? Is it just the opposite of El Niño, bringing cooler temperatures and flipping the script on weather patterns?
La Niña does tend to reverse some of El Niño's effects. For example, areas that typically experience droughts during El Niño might see increased rainfall during La Niña and vice versa.
Okay.
But it's not always a simple flip of the switch. La Niña has its own unique characteristics and can lead to some unexpected outcomes as well.
So La Niña is more than just El Niño's mirror image. It has its own personality and its own set of impacts on the global climate system.
Exactly. For instance, La Niña events are often associated with increased hurricane activity in the Atlantic, which can be devastating for coastal communities. They can also intensify the monsoon season in some regions, leading to increased rainfall and flooding.
So whether it's El Niño, La Niña, or even this mysterious El Niño Modoki, these shifts in the Pacific have far-reaching consequences for our planet. And with climate change adding another layer of complexity, understanding ENSO in all its forms is more crucial than ever.
Absolutely. The more we learn about these interconnected climate patterns, the better prepared we'll be to adapt to the challenges of a changing climate.
Well, I think we've covered a lot of ground today. We've learned about El Niño's global reach, its historical significance, and even its potential role in mass extinctions. We've also delved into the complexities of El Niño Modoki and La Niña, recognizing that ENSO is a multifaceted phenomenon with a range of impacts.
It's been a fascinating exploration, and I hope our listener has gained a deeper appreciation for the power and complexity of El Niño and its role in shaping our planet's climate.
Me too. But there's still so much more to discover. We haven't even touched on how El Niño interacts with other climate patterns around the world. It's like a grand symphony of interconnected forces, each playing its part in shaping the global climate system.
That's a great analogy. El Niño is just one instrument in a vast orchestra of climate patterns.
Yeah.
And understanding how these different instruments interact is crucial for comprehending the complexities of our planet's climate.
So, get ready for a deeper dive into the world of interconnected climate patterns. We'll explore how El Niño interacts with other key players, like the Madden-Julian Oscillation, the Pacific Decadal Oscillation, and the Pacific Meridional Mode, revealing a complex web of interactions that shape our planet's weather and climate. Stay tuned.
Welcome back to the deep dive. Last time we explored El Niño's global reach and its impact on different regions.
We also took a fascinating trip down memory lane, uncovering El Niño's historical footprint, going back thousands, even millions of years.
Now get ready to explore how El Niño interacts with other climate patterns, adding another layer of complexity to this grand planetary dance.
El Niño has dance partners. Tell me more.
One of its most notable partners is the Madden-Julian Oscillation, or MJO for short.
The MJO.
It's like a traveling pulse of increased rainfall that circles the globe near the equator, influencing weather patterns as it goes.
So it's like a rain cloud on a world tour.
Exactly. And research suggests that the MJO can actually influence the development and strength of El Niño events.
So the MJO can give El Niño a boost, making it stronger or helping it form in the first place. It's all starting to sound like a very elaborate, interconnected dance.
It truly is. Another important dance partner is the Pacific Decadal Oscillation, or PDO.
Yeah.
The PDO is a long-term pattern of sea surface temperature variations in the Pacific that shifts between warm and cool phases every few decades.
Okay, so that's a much slower rhythm than El Niño's 2 to 7 year cycle. How do they interact?
Well, the PDO can create a backdrop of warmer or cooler water in the Pacific, which can either amplify or dampen the effects of El Niño. For example, a warm PDO phase can make El Niño events stronger and more impactful, while a cool PDO phase can have the opposite effect.
So it's like the PDO sets the stage and El Niño puts on the performance. It's fascinating how these different climate patterns interact and influence each other, creating this complex tapestry of global weather.
And then there's the Pacific Meridional Mode, or PMM, which is another key player in this climate dance. The PMM is a pattern of coupled changes in sea surface temperatures and wind patterns in the North Pacific that can actually trigger El Niño events.
Hold on, so the PMM can act like a choreographer influencing the steps of El Niño.
That's a great analogy, and scientists believe that climate change might be strengthening the PMM, potentially leading to more frequent or intense El Niño events in the future.
Wow, it's incredible how everything is connected. It's like a giant puzzle, and we're slowly piecing it together, learning about these intricate relationships in the Earth's climate system.
Exactly, and the more we learn, the better we can understand how to navigate the challenges of a changing climate and protect our planet for future generations.
I think we've covered a lot of ground today, from El Niño's global impacts and historical significance to its intricate relationships with other climate patterns.
We've seen how this powerful phenomenon has shaped our planet for millions of years, influencing everything from weather patterns to ecosystems, and even potentially playing a role in mass extinctions.
We've also explored the different flavors of El Niño, recognizing that it's not a one-size-fits-all phenomenon.
From the classic El Niño with its warming in the eastern Pacific to the intriguing El Niño Modoki characterized by warming in the central Pacific, each variation brings its own unique set of impacts.
And let's not forget La Niña, the cool phase of ENSO, which often reverses some of El Niño's effects, but also has its own set of quirks and consequences.
It's been a whirlwind tour of this fascinating and complex phenomenon, and I hope our listener has gained a deeper appreciation for the power of El Niño and its role in shaping our planet's climate.
Me too. We've learned so much today, and I'm already eager to dive into the next deep dive.
Remember, this is just the tip of the iceberg. There's a wealth of information out there, and we encourage you to keep exploring and diving deeper into the mysteries of El Niño and our changing climate.
Before we sign off, we always like to leave you with something to ponder, a question inspired by our deep dive.
Today's question is a big one. If El Niño events might have contributed to mass extinctions in the past, what does that mean for our future in a changing climate? It's a question that scientists are actively researching, and the answers could have profound implications for our understanding of the Earth's climate system and our place within it.
It's a reminder that we're all connected and that seemingly distant events can have far-reaching consequences.
It's a call to action, urging us to learn more, stay informed, and work together to protect our planet.
Thanks for joining us on the Deep Dive. Until next time, keep those brains buzzing. Welcome back to the Deep Dive. We've been on quite a journey exploring the fascinating world of El Niño.
We've seen how this powerful climate pattern shapes weather across the globe, from droughts in Africa to floods in South America.
And we've learned how scientists track El Niño using clever methods like the Southern Oscillation Index,
Right.
measuring the pressure difference between Tahiti and Darwin, Australia.
It's remarkable how seemingly small changes in the Pacific Ocean can have such far-reaching consequences, influencing weather patterns and ecosystems on a global scale.
We even uncovered El Niño's fingerprints in Earth's history, reaching back thousands, even millions of years. It's incredible to think that this climate pattern might have played a role in shaping civilizations and even contributing to mass extinctions.
But there's one more fascinating aspect of El Niño we haven't explored yet, its connection to other climate patterns. It's not a solo act, you see. It's part of a complex web of interactions in the Earth's climate system.
Okay, so El Niño has some dance partners. Tell me more.
One of its most notable partners is the Madden-Julian Oscillation, or MJO for short. The MJO is like a traveling pulse of increased rainfall that circles the globe near the equator, influencing weather patterns as it goes.
So it's like a rain cloud on a world tour.
Exactly. And research suggests that the MJO can actually influence the development and strength of El Niño events.
So the MJO can give El Niño a boost,
Hmm.
making it stronger or helping it form in the first place. It's all starting to sound like a very elaborate, interconnected dance.
It truly is. Another important dance partner is the Pacific Decadal Oscillation, or PDO.
Okay.
The PDO is a long-term pattern of sea surface temperature variations in the Pacific that shifts between warm and cool phases every few decades.
Okay, so that's a much slower rhythm than El Niño's 2 to 7 year cycle.
Yeah.
How do they interact?
Well, the PDO can create a backdrop of warmer or cooler water in the Pacific, which can either amplify or dampen the effects of El Niño. For example, a warm PDO phase can make El Niño events stronger and more impactful, while a cool PDO phase can have the opposite effect.
So it's like the PDO sets the stage and El Niño puts on the performance. It's fascinating how these different climate patterns interact and influence each other, creating this complex tapestry of global weather.
And then there's the Pacific Meridional Mode, or PMM, which is another key player in this climate dance. The PMM is a pattern of coupled changes in sea surface temperatures and wind patterns in the North Pacific that can actually trigger El Niño events.
Hold on. So the PMM can act like a choreographer influencing the steps of El Niño.
That's a great analogy, and scientists believe that climate change might be strengthening the PMM, potentially leading to more frequent or intense El Niño events in the future.
Wow, it's incredible how everything is connected. It's like a giant puzzle.
Yeah.
And we're slowly piecing it together, learning about these intricate relationships in the Earth's climate system.
Exactly. And the more we learn, the better we can understand how to navigate the challenges of a changing climate and protect our planet for future generations.
We've only just scratched the surface of El Niño's complexities. It's a reminder that there's always more to learn, more connections to uncover, and more to understand about our dynamic planet.
It's a fascinating journey of discovery, and we encourage you to continue exploring the intricacies of El Niño and its impact on our world.
Thanks for joining us on the Deep Dive. Until next time, keep those brains buzzing.